Alright, this is our factoring worksheet that we had in class as classwork. We left off in the first video at problem number 7, so I'm going to go on to problem number 8 now. And I'm going to look at this one. I'm going to see, no GCF, and so this is a binomial. And this binomial, I have squares in them. I see the squares as my first term is a square, and my second term is a square. And so I have a difference. So this is a difference of squares, and a squared minus b squared. I need the root plus the root minus the root. Remember, that's called the conjugates. So I'm going to make this look like x plus 2x, or excuse me, not x, 1 plus 2x, and 1 minus 2x. And that's how I'm going to make those look. And that's one option. Remember, there's another option that we could, first of all, make our leading coefficient be positive and factor out a negative, giving us 4x squared minus 1. And then we could factor this as a negative of 2x plus 1 and 2x minus 1. And remember, this again may be the way we'd want to factor it if we were going to be using this in rational expressions and things like that. So this is another option. And I'm not picky about this. I don't need to see this negative factored out. It's perfectly acceptable for you just to do it that way on a test. But keep in mind, for rational expressions, you may need something else. Moving on to problem number 9. Problem number 9, the first thing I see is that I have a lot of variables, and so that leads me to believe that I might have a GCF. So I see, in fact, that there's a y to the 4th power in every single term. So I know I'm going to take out at least a y to the 4th, so I'm getting ready for a GCF here. And then I also see there's an x in every term, so my lowest exponent is an x squared, so I know I'm going to take an x squared out. Now I also notice that there is an 8 in common in every term, right? This 32 has an 8 in it, 24 has an 8 in it, and 8 has an 8 in it. So I'm going to take out 8x squared y to the 4th. And then I'm going to prepare myself for the 3-term polynomial that I'll get when I factor them out. So if I factor 8x squared y to the 4th from 8x to the 4th y to the 4th, I'm going to end up with an x squared. When I factor it out of 24x cubed y to the 4th, I'm going to end up with a 3x. And when I factor it out of a 32x squared y to the 4th, I will end up with a 4. Now again, this trinomial, I want to see if it factors anymore. And in order for it to factor, I would need the factors of 4, 1 and 4, or 2 and 2, that are going to give me a difference of 3. Well, 4 and 1 give me a difference of 3, so I can factor this. So 8x squared y to the 4th, that still has to come down, and then I'm going to have a binomial times a binomial. And in the leading coefficients, we're just going to have x's, and then I need a 4 and I need a 1. Now here's where I go to my middle term to decide on signs. The larger sign is going to be the positive, like the middle one, and the smaller sign is going to be its opposite, a negative. And there we go, all factored out. Now moving down to problem number 11, you'll notice that a couple of these got misnumbered on the worksheet, so it looks like we have missing problems, but we don't. Now this one can be really tricky. One of the things that a lot of students want to do is clear it. You can't clear it, okay? Clearing it is something you do with an equation. So you can't clear this because it is not an equation, it is an expression. Now that doesn't mean that you couldn't say that this represents 81 100ths, right? And that's x squared, and that this represents 36 100ths, and that's x, and this represents 4 100ths, and then notice that they all have 100 in common and factor out a 1 100ths as a GCF. Now that would certainly work, in which case you would end up with 81x squared minus 36x and then plus 4. That would be one way to deal with this. But you see, the 100th didn't just go away. We can't just get rid of it. And then the next thing that we would do if we had attacked it this way is we would see that this is a perfect square and this is a perfect square. So 9 here and a 2 here, and then I will need to check is 2 times 2 times 9 equal to the middle term, and it is. So that's a perfect square trinomial. So this could look like 1/100th times 9x, and then 2, and then quantity squared, and then the middle sign goes in here. So that would be one way that this could look. Now, that is not the only option. The other option is to simply say that 0.81 is a perfect square. It's 0.9 squared, and 0.04 is a perfect square. It's 0.2 squared. And then we have 0.9 times 0.2 times 2, which again does equal 0.36. So then we could look at this, and I'm going to do this in a different color. We could use this to say that this looks like 0.9x, and then a 0.2 here, and this is quantity squared, and the minus goes in the middle. So there's two different ways of looking at this problem. And again, it would be very much dependent upon if we were doing something else with this problem or we were just factoring it to factor it. Now, factoring to factoring, I wouldn't do this over here. I would simply do this problem right here. But it'll very much depend upon the application. Now, moving on to the next problem, we have a 1/49th minus z squared. So first thing I look for is a GCF, and there's nothing in common with those. And so the next thing I see is it's a binomial, and it's a difference, and I have a square here, and as it turns out, right, 1/49th is a perfect square as well. It's 1/7. So I have a difference of two perfect squares. So I'm going to form the conjugates. So I'm going to have a 1/7 plus a z, and a 1/7 minus a z, and that's perfectly acceptable to factor those just like that. However, you might say, oh, well, you know, this really should be written as an opposite of a z squared minus 1/49th, because that represents the leading coefficient being positive versus it being negative. And if you had done that, again, you would have a negative of a z plus a 1/7 and a z minus a 1/7. And so, depending upon how you see it, the applications that you may be using it for, that may be the better way to do it. So I always want to remind you that there are two ways to factor these where we can possibly take this negative out. And most of the time, it's going to be something that we want to do just because we will have application for these. Now the next one, I'm going to order this one first, right? I'm going to make it go b4, b to the third, b to the second, and then b to the first. Now you'll notice they all have b's in them. So the first thing I'm going to do is I'm going to take a b out, and that's going to leave me with a b cubed minus a b squared plus a b, and then minus a 1. Now here we have a 4-term polynomial. So I'm going to factor by grouping. So I'm going to take out a b from the first term, and it's going to be squared, and it's going to leave me with a b minus 1. Now the second ones, there's nothing in common except for a 1, so I'll write 1 times b minus 1. And now what I'll see is that I actually have a GCF between this first term here and this second term here. And that GCF is a binomial, so I already have my GCF of b, and now I have a second GCF, b minus 1, and now I'll prepare myself for the two terms that are left and put a plus in between these. So we have b squared for my first term, b squared for my first term, and 1 for my second term. And then I have my factoring done. All right, now moving on to my next two problems. The first one we see here is a GCF going on with these three terms. So I'm going to write that GCF out, p minus 3, and then I'm going to get 2p squared, and then plus 7p, and then plus 6. And then I'm going to have this trinomial to look at, so I'm going to take 2 and multiply it by 6, which is going to give me a 12, and then I'm going to look at the factors of 12, 1 and 12, 2 and 6, and 3 and 4, and I'm going to look for those factors that sum to 7. Well, the 3 and 4 can do that. So I have two choices. I can either do factoring by grouping, by expanding the middle term here out into two separate terms, or I can make the products of 2 and 3 with the factors of 2 and 6. Since how 2 is a prime number, I'm just going to go with that because it's easy to factor. And it's easy to see that then with the factors of 6, 1 and 6, or 2 and 3, it's easy to make the factors 4 and 3 as products. So if I put the factor of 6 out here, that is a 2, and the factor of 6 in here, that is a 3, you see my outside product is 4 and my inside product is 3. So I'm going to put a plus in between each of these, and I will be done. And now I'm way over my 10-minute limit that I set for myself, and I need to stop on this one and pick up on another video.